Do you feel the vibes?
Okay, so we did this last time. Right. So, um, so if you have a vector and if you know the magnitude, and the angle that a vector v makes with the positive x-axis, right? Then you can decompose v into its horizontal and vertical components using trigonometry. So if you have a vector v, and if you know this angle, and if you know this magnitude, right, then you can decompose this into its horizontal and vertical components, and you can come up with these, okay? And the way in which we did that, right, we did that in the previous lesson, is for the x component, remember it was always v cosine theta, and for the y component, it was always v sine theta. So another way to write that is, using that. Or you can say v cosine I plus v sine j, okay? So we want to find the component form of vector v with magnitude 7 and direction angle 60. So v is just 7 cosine 60, 7 sine 60, right? And what's cosine of 60? 3 over 2. So this is 7 times 3 over 2. And then this is 7 times a half. Right? Oh, no, the other way around. This is a half. And this is root 3 over 2. Multiply. 7 times a half. So
that would be a no calculator.
Huh?
That would be no calculator.
Well, so if it's on the non-calculator part, you can definitely say 7 over 2 and then 7 root 3 over 2. That is definitely an acceptable answer. But then in decimal, this will be 3.5. And how much is this?
6.06 something. How do you do that? I didn't know the calculator. Oh, we're so smart.
Yeah. Okay.
And then we have to write it. Oh no,
It just says component form, so that's it. And if you had to put it in, as a linear combination of I and j, you would.
Do you always want us to put problems in decimal form?
So it depends. If it's on the non-calculator part, you wouldn't. And then if it's on the calculator part, it will specify.
And do we have to rationalize if we get
No more rationalizing.
Yeah.
That's so algebra. That's so last year. It is Throwback Thursday today, so it's okay.
You don't have to.
So
you don't have to rationalize on the AP test.
Yeah. So listen. Remember, to always be in degree mode, right? Because you're in degrees. I mean, I don't have to remind you guys that. Okay. All right. So now we have a vector p. Okay. We want to find the direction angle of vector p. So let's see what that looks like. Vector p is 9, 5. So if this is 9 and this is 5, that's what vector p looks like. Direction angle is this. So this is what we're looking for. Right? We're looking for that angle. So how would one find that angle? Exactly. This is 9 and this is 5. So tangent of theta is just the y over the x, or, b over a, right? So it's 5 over 9. So theta is inverse tangent 5 over 9, which is 29 degrees. Okay, now we need to pause here and we need to go over a couple of things. First, you know how I drew that diagram? You don't, I mean, normally we don't do that, right? Because it's just the y over the x. I mean, if you did draw it, it's fine, but it's just, you don't need to waste your time. Okay, now comes this other part. You have to make sure, because the direction really matters, you have to make sure that your angle really corresponds with the correct direction of the vector. What do I mean by that? Suppose your p vector was negative 9 comma 5. What does that look now? What does that look like? Here.
Quite a bit bigger of an angle.
Right. So now we go on the calculator, and it would still be inverse tangent of 5 over 9, right? So let's do that. Oops. Inverse tangent of 5 over 9.
Can you do 5 over -9?
Oh, I am in radian mode. Okay. So for argument's sake, suppose you do this. And you know 29 degrees is not what the answer is, right? So you have to account for that. Now, suppose you did negative 5 over 9. Now you get negative 29. Where does negative 29 point? In the fourth quadrant. This is still not what you want. So what you want, so this gives you theta equals negative 29 degrees. What you want to take is the reference angle of that. What's the reference angle for negative 29? The reference angle is 29. Right? Because look, it's right here. The reference angle is always the absolute value between the terminal site and the nearest x-axis. So that's the reference angle, 29. Now the angle that you want is this. So that's going to be 180 minus 29, which is 151. Okay? And so you would have to adjust depending on the quadrant that your angle falls in. If your angle fell in the third quadrant, what would you do? 180 plus 29. And if it was in the fourth quadrant, what would you do?
180 minus 180 minus
360.
360 minus. Okay?
Oh, so it's not it's SATC or not? Like, what? He said like the
So it doesn't have to do with that. You take the reference angle, and you know you have to be that much away from the x-axis. If you're here, it'll be 360 minus that, because you have to go from the 0 and over.
Oh, so but you can just like see that, you know.
Right. So if your p was 9 and negative 5, it would be here. Right? So this is 29. That means this entire thing would be 360 minus 29.
So it's over positively
From 0. Yeah, you have to start counting from 0 and go over. Okay. Now, a quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second at an angle of 40 degrees with the horizontal. What is the resultant speed and direction of the pass? So here's a little bit of like physics for you. If the person was just standing there and they threw it, the ball would have a velocity of 25 meters per second and an angle of 40. But the fact that he's doing that while he's running, that changes the velocity and the direction of the ball, right? You know how like in the airports when they have like the moving, the walkways, right? Yeah, the moving walkways. When you're walking on that, you're actually walking a little bit faster than the person walking next to you even though you're at the same speed. Have you noticed that? Because it's like your speed and the speed of this. So it's kind of similar to here. So what are we going to do here? Well, there are two vectors. One is this vector of the ball. So the ball is going at 25 meters at an angle of 40 degrees. Then there is also the quarterback himself, the player, 5 meters per second running forward. So basically what's happening is, here's the player. That's the player's vector. And then you've got the vector of the ball that makes an angle of 40 degrees with the horizontal. Because remember, to add vectors, you start where the first one left off. Yeah? So this is how the diagram will have it. But in order for us to add vectors, you have to put one at the end of the other. Okay? So what we want is the resultant speed and direction of the pass. What is the resultant? Oh, it's this. This is it. So what we have to do is the following. We have to write down the two vectors. The first vector of the player is the player's going in the horizontal direction at a magnitude of 5. So that vector is 5, 0. So your first step is to write the vectors in component form. The second vector is the vector of the ball. And that one, remember, if we know magnitude and direction, it's just cosine and sine. So it's 25 cosine 40, 25 sine 40. I put those in my calculator. Okay. What do I get for 25 cosine 40 to 2 decimal places?
Why didn't you have to do cosine and sine for the 5?
Because you can. What's the angle though? It's 0. 5 cosine 0. Cosine of 0 is 1. 5 sine 0. Sine of 0 is 0. So it'll still be the same. Right? Does that make sense?
Why are you?
Yeah, it's math. It's got to.
No, it makes sense. It's like
So when the thing moving is always just horizontal or just vertical, you can just circumvent that stuff and just write it.
But like, why isn't then the 25 and the 25 and 0 with the magnitude of it?
Right, but that one has an angle. The ball is being thrown at an angle of 40. The person is just moving forward at an angle of 0. Okay? So when you do 5 cosine 0, that's 5 times 1 and then 5 times 0. Okay, what was the first one? Did you do the first one?
With the component form for vector B.
Yeah, this one.
It's 19.15.
Yeah.
Comma 16.07.
Okay. Yeah.
So you're doing like cosine and sine of the angle in order to find what this line is and what this line is. Okay.
Yeah. And so the units of this, by the way, are written like this. Meters per second, meters per second. Yes, that's exactly what I'm trying to find.
Okay. Just wanted to make sure I understood it.
Yeah. Now, second step is we want to add the components to find R. So R, which is vector P plus vector B, is I add the first with the first, 24.15 meters per second. And then the second with the second,
16.07.
right. So that is the component form of this. This vector is going 24 this way, 16 that way. Okay? All right, so what were we asked for? We were asked for the resultant speed and the direction. The resultant speed is the magnitude of r. If this is r, can we find the magnitude? Yeah. So number 3, find the magnitude. That's the square root of the first number squared plus the second number squared. But we're going to use the values that we got, the full values. So why don't we do that? Let's do it using storing variables. So take out your calculators, do this with me. So in the first case, we had 25 cosine 40. Okay. I pressed, okay, I got the answer. Now, second variable or control variable, I'm going to store this as A. Cool? Now let's do 25 sine 40. I'm going to store this as B. Yes? Now I'm going to do square root of A squared plus B squared. That should not be 25.
You forgot to add 5 there. It's A plus 5.
Oh my God. Oh, look. I only did B. And look, I did get 25, which was actually the magnitude of B. Do you see what I did? I did something stupid, but it's actually cool. Okay, so let's just do it again. So, actually, it's this.
29.0088.
What are these things? Okay, 16.07, the B is right. Okay, but this is supposed to be A plus 5. And then I'm going to store that as the new A. So that's the A. So now let's do A squared plus B squared. There we go. It's 29.01.
You want to round to 10 or 100?
It will specify meters per second. 29.01 meters per second. Okay, now the direction is going to be theta is equal to inverse tangent of, in this green, 16.07 over 24.15. Why? This is the vector in green. You want to find the direction of that. Remember, just like how we did it here, you just do y over x. So in the calculator, though, it's going to be inverse tangent of A over B.
Not A. No, not A. You changed A.
B, no, A is the new A. It's B over A. Oh, I could get my calculator. So inverse tangent of B over A.
Wait, is it 24.15 over 16.07 or other way? Oh yeah, other way. This 16
Yeah. Okay. So how much is it? Theta is 33. Now, do we need to adjust this for a different quadrant? We do not, because look, this is pointing in the first quadrant and this is in the first quadrant. All right? We did it.
Wait, what'd you get?